we've got to make a mold box, and then finally we've got to do the pour. So it's basically going to be those 3 steps. So the first thing is to do some planning here. So probably the thing that we need to know more than anything is how big is our mold box. So this is the thing I'm going to mold. This is out of the bigger mold, but I'm going to use it anyway. It's pretty tall. And what I did is I went ahead and I took some measurements with this ruler here. And one of the things that you're going to see me do during this whole demo that's going to be a little strange is all of my measurements I'm going to call out in centimeters. So far you've heard me talk about millimeters, you've heard me talk about decimal inches. Today I'm going to talk about centimeters, and I'm going to get into why I'm going to use centimeters when we start to talk about volumes. So here's my dimensions. I measured it this way, I measured it wide, and I measured it tall, and I'm basically looking for the tallest points, right? So the tallest point is probably the tip of my nose. That's where I'm going for. The widest part is probably right here on my jaw, and then I'm going from chin to tip of temple here. And the measurements I got for this are 70 millimeters by 40 millimeters by 40 millimeters. Now this should be relatively easy for you guys, right? Because you've got this object in CAD, you can just drop a bounding box on it, you can get the dimensions of the curves of the bounding box, and that'll tell you exactly what the dimensions are. But I had to go old-fashioned and use the ruler because I don't know where this file is. So when we make the mold box, we want our mold box to have margins, right? And those margins are what are going to form our walls on the side and our thickness on the top. Ooh, that's a bad mold. See how bubbly it is? It's pretty terrible. So, rule of thumb, if you look this up on the internet, typically they'll tell you like, I don't know, they're wild numbers, like a half-inch margin on the edges of these molds. Like, to me, that's too much. So my rule of thumb here is about a 1/4 inch, right? I'm a rule of thumb guy, and so like I have like some numbers that are buried in my head. And one of them is a 1/4 inch. Now this gives us sort of a weird number. A 1/4 inch is like 6.35 millimeters, or 0.635 centimeters. So what I'm going to do is I'm just going to say if we just go to 10 millimeter margins, that'll make our margins all 1 centimeter, and that makes our life a lot easier. Because then what I can do is I can come down here and I can just say, if I just add 10 to each direction, right? This little diagram here is sort of showing our object sitting in the middle of our mold box, and we just add 10 millimeters in each direction, then that'll give us a good margin on the edges for our mold.
For a two-part mold, do we need 1 centimeter on the bottom? Is that fair?
Yes, all the way around. So if you're doing in the round mold, all of this sort of translates from 2D to 3D. So if that's the case, and I want 10 millimeters of margin here, I want 10 millimeters of margin on the top as well, right? Then this makes this pretty easy. I actually did my math wrong, so I'm a little dumb. That's all right. So what I did here is I took 70 and I added 10 millimeters for both sides. I took 40 and I added 10 millimeters for both sides. And then for the height, I just need the height plus the margin on the top, right? Because this is an open mold, there's no margin on the bottom. So this one is 40 millimeters plus our 10 millimeter margin. And that gives me dimensions of my box of 90 by 60 by 50. Right? So what that means is that I know how big the bottom of my box is. My box is going to look like this, right? We're going to have 90 in this direction, 60 in this direction, and then this 50 number. This confuses a lot of people. What does that 50 number represent? Well, that 50 number represents, if we were to sort of describe our mold as a prism, which we're essentially going to do, 50 describes the thickness of our mold, right? This is our 50 number. But we need our walls to be higher than the top of our mold, right? Because if it's not, we just spill out. So here's a trick question. How tall do the sides of our mold box need to be?
60.
60? Anybody else?
More than 50.
More than 50? Anybody else? So the answer is actually infinity. They can be as high as we would want them. They could go to the moon as long as they're taller than the top of the mold, right? So be careful with this, because every semester it feels like someone cuts their mold box so that the walls are as tall as their mold, and then we have a problem because we've got to degas it. We need some headroom for this to bubble up a little bit. So you need to make your mold walls taller than the top of your mold. How much taller? I would say give it at least 10 millimeters, right? But they can be as tall as you want, right? That's sort of the thing is you don't really have to worry about the height of the walls as long as they're taller than the size of the box, or the height of the mold. All right, so I've got this hot glue gun cranking, yes, and I've cut my mold box here, and you can see what I did is I labeled these. I gave myself a north, and then I sort of labeled them east, south, and west, and that's just for me to sort of line them up. Like the other way that people do this, what do I do with my pen? Yeah, let me borrow your pens. The other way you can do this is like this, and you've probably seen this if someone's like a carpenter in your family, right, where they do this number. 1, 2, 3, 1, 2, 3, 4, right? And now I know which side is which. You just need a way of identifying which side is which. Alright, so now that I've done that, what I can do is I can start to assemble this box. And I'm going to start with the two sides here because I'm pretty sure, let's just double check how I built this. Typically the way that I do this, yeah, is I will lap sides. So what I'm going to do is with the two sides of the box, I'm going to make it so that they sit up on the bottom, and then I'm going to try to turn this so that you guys can see this. It's a little hard to sort of articulate, but basically what I want is I want all these sides to sort of lap over each other like this. So this one's sitting on top, and then this one is going to sort of cap the sides like this. Alright, so that's the way I'm going to put it together, and I'm going to use a hot glue, and you'll notice that what I'm going to do is I'm going to go to the inside, and I'm going to run a bead almost like a fillet along the edge. I'm going to wait for hot glue to set up. And what I'm trying to do here is I'm trying to seal this box. This box has to be watertight. If it's not watertight, then the mold material will just leak out of it and you'll be sad. Probably the smarter way to do this would be to tack the sides with super glue, and then let's actually do that. Tack it with super glue, and then hot glue. We're gonna have the super glue sit right here. This step takes a little time to set up too, though. This is like 10-second super glue. It's not like a 5-second instant bomb super glue. I'm just gonna push ahead because I don't want to sit here and waste everyone's time watching me hot glue shit. It's pretty boring. Alright, so I've got two of the walls on. Now what I'm gonna do is I'm gonna stop gluing walls for a second because I need to get my mold, my object, into my mold. And with the sides off of it, it's probably a little bit easier than doing it with the sides on it. So I'm just going to sort of position this. I want to try to get it in the center. And once I feel like it's there, this one's been used before. Let's see if I can get some of this shit off of there. You can see that this has been used before, so I have actually glued this down. Don't do what Aaron does. Anybody tell me what I'm doing wrong here? Yeah. Don't do what Aaron does. That's good enough. Alright, so to get this to stick down, I'm literally just going to super glue this down. All this is sacrificial anyway, because the thing we're making is the mold itself. So I'm just going to super glue, and then I'm going to eyeball to the center, and I'll get a little bit of working time before that sets up. Alright, now I can go ahead and finish my mold box. Whoops. Where I can just destroy it. So again, the sides, as long as these sides lap over the length here, isn't super important. Right? As long as we've got a good lap, we're good to go. And again, I'm going to try to come inside here and seal as much of the inside of the box as I can. Start talking about everybody's favorite thing to talk about in this class, which is math. It ain't pretty, but it'll do the job. This one's the hardest one because the box is so deep. I'm actually going to spread that around on the bottom. And then what I'm going to do just for insurance is I'm going to come up on the outside and I'm just going to seal up all these seams as well. Again, this is not a beauty contest. What I care about more than anything with this is not leaking. This won't sit flat on the table, but again, beauty is not a problem. Alright, so there is my wonderful mold box, hot glued to the table. There we go. You laugh, Vern. I'm going to have you clean this up later.
I didn't laugh.
Oh, you should have laughed. Alright, so there's our mold box, all done. We'll let that hot glue set up as it burns my fingers a million times. Alright, so what we've got is we've got this box now with these dimensions here, and we need to fill this with smooth. And this is the goo that's going to fill it. This is Smooth Sil 940. This is a platinum curing silicone rubber. And so this is what our mold is going to be made out of. This is a 2-part silicone, this is part B, and this wonderful bucket part A. So this is the consistency of this stuff. So let's learn a little bit about Smooth Sil. Smooth Sil 940, it is a platinum curing silicone. We have a mix ratio of 100A to 10B. So this is essentially 10 to 1 mix ratio. The specific gravity of Smooth Sil 940 is 1.18 grams per cubic centimeter. We have a cure time of 24 hours and a pot time of 30 minutes. So cure time is how long it takes for the mold to completely set up and be ready to demold and use. Our pot time is essentially our working time. So what this means is when we mix part A and part B together, we've got 30 minutes to get it in the mold or else we're done. Right? Once we reach over 30 minutes, then the stuff starts to set up. Now the stuff I'm using today is pretty old stuff, so I don't know, usually the older the silicone is, the quicker it wants to go off, which means the shorter the pot time is. So we'll see. This is actually probably why this mold is so bubbly, is because again I used some old stuff and this stuff set up real quick. So why do we need to know all of this shit? Well, because we need to figure out how much stuff we're going to put in here, right? So the easiest way to figure out how much stuff to put in here is to use a little map. And it's all based around this little guy, the cubic centimeter, right? Which is the reason why we did all of our measurements in decimal or in SI units, is because now we can easily convert this to 9 centimeters by 6 centimeters by 5 centimeters. And what this is going to tell me is this is going to tell me the volume of my mold in cubic centimeters, right? So all I need to do is multiply those values together. Now this is really important to do this in centimeters and don't do this in millimeters. If you do this in millimeters, you're going to get a gigantic number. Everybody's mold should be less than 1,000 grams. If you get more than 1,000 grams, then you've done something wrong. So I'm going to take 9 times 6 times 5. And that's going to give me 270 cubic centimeters. So that is what is going to be the volume of my mold. So what I have to do is I have to convert this number over into some sort of value that I can measure on this scale right here. This is a very sensitive gram balance scale. You guys can't see this. I'll turn it sideways so that some of you can at least see it. You can actually unplug the hot glue gun so I don't burn myself. But this is a very, very sensitive scale. This scale is actually so sensitive that sometimes if you vibrate the floor, it will actually pick it up. I know that if I vibrate this table, I can get it to jump around. So just be careful with this scale. The one thing that you do not want to do on a scale like this is you do not want to press down on it. If you press down on it, you damage the load cell that's in there, which is bad. So do not press down on it. Oh, I'm missing a piece. Let me go get a mixing cup, because I am missing a mixing cup. Now, what we got to do is we've got to figure out how much stuff we need, because I'm going to weigh it, and right now I have a volume. So here is the magic. The magic is that 1 cubic centimeter of water at 32 degrees weighs how much? Does anybody know? 1 gram. Okay. 1 cubic centimeter is equal to 1 gram. This is kind of the beautiful thing about SI units. So, if I know that my mold is 270 cubic centimeters, how much total material am I going to need to fill this mold in weight?
270
grams.
270 grams. Of what? Water. Right? Because this is water. And we could say at 32 degrees. What happens is the temperature of that water goes up, by the way.
Density gets lower.
The specific gravity goes down, yeah, because it's less dense. So if this is 270 grams of water, how much of this stuff is it? So in order to know that, what we need to know is we need to know the difference in density of this material compared to the same volume of water. And that is something we call the specific gravity. Have you ever heard the term specific gravity? So when we talk about specific gravity, we're really talking about, is something less dense than water or is something more dense than water? Will it float or will it sink? So water has a specific gravity of 1 because we sort of measure everything based on the density of water. You don't notice like water is showing up over and over and over here, right? So specific gravity of water is 1. The specific gravity of Smooth-On 940 is 1.18 gram per cubic centimeter. So what this tells us is that smooth on is what?
Heavier.
More dense and therefore heavier, right? So if we know that this is heavier, then we know we're actually going to need less than 270 grams. And we can calculate exactly how much less just by taking 270 and dividing it by 1.18, which gives us a total 228.813, and so I'm going to round this to 229 grams. Cool. Yeah. Which number? There are a ton of numbers here. 229. What we did is we took our 270 grams of water. That's not an eraser. That is a sanding sponge. This is probably the most dangerous thing you can put next to a whiteboard. What we did is we took 270 grams of water and we divided it by the specific gravity, and that gave us, what did I say, 229? Approximately 229. It's not exact. It's like 228.813. Yeah.
So is it easier to weigh than to measure it with the volume cup?
I mean, think about your experiences in the world. Do you cook?
Yeah.
So have you ever measured like a cup of milk?
Yeah.
How hard is it to get exactly 1 cup of milk?
The line?
Yeah. You have to like get down there and you're doing one of these, or you just do it from up here and you're like close enough,
Yeah, close enough.
right? So here, close enough doesn't work.
No.
So we need to know exactly how much stuff is in there,
Okay.
and the easiest way to do that is just to weigh it. Because anybody bake? Anybody a baker? When you measure flour out, how do you typically do it? Do you do it by volume or do you do it by weight? Why? Because the volume can change. So the same amount of weight of flour can actually be a lot bigger in volume if it's fluffy, or a lot smaller in volume if it's compact. And so those sorts of measurements can get like fuzzy. And especially when you're doing something like this, where the ratio of the two materials really control the reaction rate, we don't want fuzzy. So we're always going to weigh.
Okay.
All right. So now we're ready to weigh, right?
Wait, but isn't the whole, like the mold is like half of the volume?
Huh?
The actual mold, they're about half, let's say half of the volume?
So
their portion?
I didn't subtract the
Right.
the actual positive
Yeah.
volume out, right? So I'm going to have more material than I actually need to go in my mold. But what's going to happen is when I mix this, some of this is going to stay behind here,
Okay.
right? So my rule of thumb on this, again, this is another rule of thumb, is that I just do it all the way and ignore the volume of the mold and just kind of count that some of it's going to stick behind here. This is one of those places where you always want to shoot over rather than under. You can always not use some stuff or just pour it into a different material or a different mold than having to mix up some more shit and do it again. It just doesn't work.
And that's why you keep your walls smaller.
Yeah. Because if I have a little more and I pour a little tall, big deal.
Okay.
If I don't get all the way to the top of the part, that's a big deal. All right, so 229, we're going to hand wave the volume of the part. Are we ready to mix up material? Say it loud. You have to figure out this ratio, right? And it's 100 to 1, or 100 to 10. So for every 10 parts of part A, we need 1 part of part B. Again, this is more sort of hand wavy stuff, but all I'm going to do is I'm going to take this number, I'm going to move the decimal place over and say 23 grams, and then I'll just add that all together, and this will give me my final volume. Technically what I should be doing is I should be taking this, I should be multiplying it by its ratio and getting the two constituent parts. But again, I'm going to be leaving some stuff behind here. I'm going to be leaving some stuff behind on the stick. I always want to make sure I've got a little extra here. We'll just add this all up. What is this? 2, carry the 1, 5. 252 grams of material total. I need 229 of part A and 23 of part B. So this is actually my final numbers here, and I want to make sure that the scale gets to 252. All right, let's weigh this crap out. So I'm going to place the scale or the container on the scale, and then I'm going to tar the scale out. This will zero it so that the weight of the container is sort of taken into account. And then I get to start mixing this. So this stuff is like taffy. It is thick. And so the best way to get this stuff out of here, ooh, this is old too. We'll see if this works. This stuff might not work. But I don't want to open the new stuff. I want to save the new stuff for you guys.
How can you tell it's old?
Yeah, there's like a skin or a meniscus forming on top. So I'm going to try to dig down in here. Now I'm going to give you guys gloves. I'll give you gloves, don't worry. So the easiest thing to do is just pick this up on a stick and just wipe it on the sides. Yeah, I don't know if this is going to go off. We'll see. So there's 61 grams, and I need to go to 229.
At this point, if you get it on your hands, is there a big concern?
You don't want to, but this stuff is actually pretty benign because it's silicone, so I'm not super worried about it, but I'll give you guys gloves when we do it so that you don't have to worry about contamination. So where I'm at, 105. I feel like this stick kind of sucks. Yeah, the stuff when it's fresher is a little more runny. It's a little more like taffy. This is a little thick, so that's another way I can sort of tell it's old. It's been sitting around for a while. So there's 174.
If you leave it, is it thin enough that it will like settle back into a flat layer?
It'll eventually sort of fall down and level itself out. So I'm getting close. I was at 199, 215, tantalizing, 218, 222. 223. Oh man. It's getting intense. I don't know if I can like just get 5 grams off in there. Maybe I can. 226, guys. Guys. 229.5. I'm actually just going to call it good. 229 and a half. All right. I'm going to scrape this off because I'm going to use this as my mixing stick. Normally we have separate sticks, one for removing the material out and another for mixing. Don't ever use a mixing stick to scoop because again, once this stuff goes in, we're on the clock. This is where the timer starts. So part B says at the very top, stir well before using. So we'll give it a shake. And what you're going to notice about this are 2 things. One, you can already hear the consistency is much different. This stuff is super duper runny. And so you really have to be careful pouring this stuff. The other thing you'll notice is its intense red color. And this is an important thing for us. So I need to go to 252. I need 23 grams, but I know I just need to go to 252, so I'm just gonna watch the scale as I pour. You can see how runny this is. Yeah, there's not much you can do with that. $2.49.
Is it drifting onto the scale?
Probably.
Yeah, it is.
$2.52. It's little enough that I'm not super duper worried about it.
I can see the puddle.
It is a small puddle. It is not an insignificant puddle, but it is a small puddle. All right. So this is basically what we have right now. And the reason why that these are two very different colors is because we want to turn this into this uniform bubblegum color. And to do that, you are going to mix. So this stuff is not wanting to come together, but we're going to see if we can force it to. This is just very old material. And I'll probably actually just throw this out after this demo's over. Because I don't think anybody else is going to be able to use it. But we'll soldier on and we'll see where we end up. So one of the things that you really want to do is you want to be checking the size of this container. Because you can actually see how much white stuff is still there. And we need to get this all to this sort of uniform pink bubble gum color. So I'm going to just continue scraping the sides and aggressively mixing. Now, this is a lot of baking questions, but has anybody ever made a meringue pie?
Yeah.
How do you make meringue?
Beat the shit out of some egg whites.
You beat the shit out of some egg whites. Why do you beat egg whites?
You're denaturizing the protein. And then you can add cream of tartar, which helps stabilize the matrix.
Yep. Because
You want it to be like fluffy. Or no, you're trying to incorporate air.
because you're trying to incorporate air, you're beating that stuff together to create a foam. So, can anybody tell me what I'm currently doing?
I didn't come.
I'm feeding a bunch of air into my silicon mold. And the air forms air bubbles. And air bubbles are our enemy because they're going to form inclusions and can cause problems when we go to mold this. So after I've got this mixed up really well, scrape it down one more time. I'm not seeing any white in the mixture. And what I'm going to do is I'm going to take this whole thing and I'm going to transfer it over to this device right here. So this is a vacuum chamber. And oh, there's my pen. I was looking for that. All right, and what this is going to do is this is going to pull a vacuum and cause this stuff to debubble. So I'm just going to drop the whole container in there. I'm going to put this on there, and then there's a switch right here. And this turns the pump on. Now when this pump fires up, it's going to be real loud, and it's going to spew what looks like smoke out of this thing. It is not smoke, this is mineral oil. It's getting atomized by the pump. So don't worry about the stuff that comes out of here. This gauge is our vacuum gauge, and there's a couple of valves on here. And the way that these valves work is when they're in line with the hose, that means the valve is open. If it's perpendicular to the hose, that means the valves are closed. This side goes to the atmosphere, this side goes to our pump. So in order to pull a vacuum, what we want is we want our pump side open and we want our atmosphere side closed. And then I'm going to go ahead and flip the switch and I'm going to give a little press on the top to make sure I get a good seal, and you should see that needle start to rise. And what I'm trying to do is I'm trying to pull this down to 29 bar, which is basically as far over as this needle will go. And what I'm going to do is I'm going to watch it. And what I'm watching for is I'm going to watch for the bubbles to rise. If you look in here, you can actually see it starting to puff up like bread. And what that is that's all the air being pulled out of the mixture. And I'm timing it for 1 minute. So if anybody wants to get a timer ready, I'll let you know when this pops. Yeah, if you guys want to look in there, you can actually see how much volume that's gained. So this is why we're using very big mixing jugs for such a small amount of material. And I can tell just by the way it's acting that it's getting ready to pop. You see how it's kind of roiling now? And now it's going to start to pop and deflate. So what is that thing? People are like afraid of holes. Yeah, if you have that, this is not what the thing that you really want to look at. But at this point I can shut the vacuum pump off and I want to hold it under vacuum for a minute.
Another minute.
Has it been a minute
9 seconds.
since it popped?
Since you said 1 minute.
Alright, we'll give it a little bit longer. This step is really important because this is what's degassing all of the bubbles that we've sort of whipped in there. By pulling this under vacuum, what we've done is we've caused the atmosphere that is captured in those bubbles, the pressure in there is higher than the pressure that's contained in the vacuum chamber, and so all that gas wants to get out of there. We're trying to it's trying to equalize the pressure here. So we'll let this sit for a little bit longer. And then what I'll do is I'll open this valve, which will release it to the atmosphere, and you'll just see all those bubbles pop all at once.
My timer just went off.
Your timer just went off? Alright, let's open it up.
When did you close the valve to vacuum?
Huh?
When did you close the valve to vacuum?
There really isn't any reason to, unless you're holding this under vacuum for a long time. You can get a little back bleed off through the pump, and so you would just clamp it off on both ends to hold the vacuum. So you'll know that this is done when you can pull the top off, and then we've got our stuff that's ready to pour. Now one more step before I pour this in here, I'm going to hit my mold with a little bit of mold release. This is just a little bit of insurance. This isn't really necessary, but this will help if we have any areas where we didn't get the part completely clean, or there's stuff on here that wants to stick to the silicone. And then I'm going to go ahead and pour. Now the way I'm going to pour is I'm going to tip the mold up at an angle, and I'm going to pour into a corner, and I'm going to allow the material to sort of come up the mold rather than just pouring all the way on the top. And again, this is the reason I'm doing this is I want to mitigate any bubbles forming. If I just pour over the top, then what can happen is I can trap a bubble along the mold. And I really just want this stuff to find its own level. And this stuff is super duper thick. I can tell that it's starting to set up already, so I'm going to just kind of cook here. Scrape the rest of this in here.
Put it in the vacuum again once.
What do you mean?
Like to get any more bubbles out.
That's exactly what I'm going to do. So I'm tapping it down just to sort of get everything to settle. And then we're going to pull another vacuum on this. Because I just poured it, so I may have introduced some more bubbles in there. So we'll go ahead and vacuum it down again. And hopefully if I did everything right, we won't see that aggressive foaming that we saw the first time around. If we do, I have screwed up. I can't hear you over the pump. Give me like a few minutes here, and I'll shut it off, and then you can ask me your question. Tell me when that gets all the way to where it needs to get. You'll just need to check all of the spaces between all the parts.
Made it to where the walls
But we only need 10
into
millimeters.
a wedge in the bottom. And I had to
You can actually go closer than that.
It
10
was,
millimeters
but
is
because the well, first of all, my wall thickness was big.
So for this, what I'm going to do is I'm just going to let it sit like this. And this over here. And then what I can do is I can literally
Yeah,
just
the
grab
actual,
this.
yeah, the was too big, and it was going into like an indented like bed, so trying to take the bottom off. I had to use a hot water,
Because what's going to happen is if you do it while it's in the mold, it will actually just foam out and flow over the mold.
So I had to
The first time you whip so much air into it, in order to get it to settle, you've got to vacuum it out. Like it was hard to see from the back, but when we vacuumed this thing actually rose all the way till it was almost overflowing.
Well, I committed used rubber bands and
Yeah, it would be, we have a mold box like this.
in particular, but it was really because I had.
So whenever you can pull that top off,
That made it.
you can go ahead and take the top off and then just reach in there and pull it straight up because it's still liquid. Don't like tip it or anything.
If one goes over 1 minute, I assume it's fine.
It's fine.
Under 1 minute.
Yeah, these are minimum. These are like minimum times essentially. There we go. So we got a little bit of mold fluid. Kind of went hard going stuff. And then this just needs to sit. So this will set up. It'll take 24 hours for this to set up. And then what you do when you're done is you literally just crack the mold box off of it. You just break the mold open, pop the part out, and you'll end up with the solid part. This is like really viscous. It's setting up really quickly. So this is what I was saying when I said like the pot time on the old stuff starts to go way down. It should be 30 minutes and I was way under 30 minutes. But you can actually see like if I poke it and pick my finger up, like it should not be that thick already. So this is just setting up. And so those bubbles on top are probably not going to pop, but I'm not super worried about the ones on the top because that's just surface tension. It's the ones, like basically what can happen is, this is like your thing. Right? And you pour the silicone on it and you like trap a bubble like right here. That's part of your part now, right? So now your part has that little wart on it, which sucks. And especially if you get like a whole bunch of bubbles trapped all over it, now your part looks terrible, right? Because it's got all those little inclusions in it. So that's sort of the name of the game. You can actually see like all those bubbles are starting to pop off now, and we're starting to get like a nice smooth bag. Let's see, is this thing cool enough to come out of here? It does not feel like it.
What's the wait time on the chocolate?
Huh?
What's the wait time on the chocolate?
Depends on the ambient temperature of the room you're pouring it in. Yeah, this one isn't done yet. Ooh, I might be able to get it out now. It's still soft. Let's see if we can pop this guy out. Yay! So there's a little chocolate Aaron, and then probably what I do is come trim this up. The other thing that can happen is when you pop your mold box off, I was doing that thing where I was cutting towards myself, and what I was trying to do is scrape all that paper off the bottom of the old one. And the reason why is that paper is going to allow the part to float up just a little bit, and that's area where the silicone can sort of infiltrate underneath that. And what you'll end up with is you'll end up with flashing. It'll look like this, only it'll be silicone on the margins of the mold. If you get that, just don't use a utility knife. Pretend this is an X-Acto knife. Get a brand new X-Acto blade. A brand new blade. Don't use an old blade. Like swap the blade from a new package onto your X-Acto knife, and then come in here and give like a 45-degree angle trim around the margin of the mold to remove that flashing. Use, and I'm going to say it like 14 times, use a brand new X-Acto knife. If you use an old knife, it's going to be too dull to really cut the silicone very well, and you're just going to end up gouging into the mold. If you have access to a scalpel, it is a better tool. Those of you who are jewelry people, I assume have access to scalpels for doing rubber molds. That's how you key a rubber mold. Scalpels work really well for trimming that flash off. That's how you make the chocolate mold. You guys have any questions? No, don't clap. Don't clap. You paid for this. Huh? You can.